So today, what is it? The 3, 4, 19. Okay, here's our objective. We're going to be finding polynomial functions or equations, right? Or equations from a scatter plot. Okay. So we're finding polynomial functions, equations, from a scatter plot. We really have, in a sense, many different types of equations. We really do. But for the polynomials, there's a linear. That's our y equals some mx plus b. And we know that if it's linear, it's going to be fairly straight, right? It's going to be fairly straight. Right? Now, if it's quadratic, we know that it's going to be some y equals ax squared plus bx plus c, and we know it's going to be a curve like a parabola. Right? If our scatter plot looks like a cubic, it's going to be some y equals ax cubed plus bx squared plus cx plus d. You know, where a, b, c, and d are just numbers that pop up on a calculator, right? And a cubic can look something like this, right? But you have to be careful because on these problems you might only see part of the graph. In fact, the last one we did that was just cubic, if you graphed it, you'll see that it looks, if you only look at the positive half, it could look quadratic, okay? If you only look at that part of it. If you cover up the rest of this and only look here, almost guess, if you didn't have any other information, you'd almost say, gosh, that looks like it's an x squared, because you don't know the rest of the graph, okay? Now quartic, same thing. Quartic is going to be an x to the fourth, a y equals and some ax4 plus a bx3 plus a cx squared plus a dx plus some e. And the thing about a quartic is oftentimes, if you don't see a lot of it, quartics usually look like W's. They can look possibly like this. They could. But if all you see is just this part of it, you might guess it's going to be a quadratic. Does that make sense? A real life problem, so this is all you see. If you don't see the rest of it because of your data, it might appear to be a quadratic. Okay? So let's make a scatter plot and take a look at this. And this is exactly the problem we just did, okay? Where we did the differences. We did this one right here. So let's go ahead and graph it. So let me go ahead and grab a ruler here. All right. So, hi Nicole. Okay. Alana's not here. No. Okay. So let's take a look at what we have. And I may have to go by tens to make this work. 10, 20, 30, 40, 50, 60, 70, 80. Yeah, I'm going to go by tens. 10, 20, 30, 40, 50, 60, 70, 80. Okay, and I'm going to go 1, 1, which is awfully hard, but I'll go by ones on this. 1, 2, 3. 1, 1 might be really difficult to see. 2, 4 again, just way down here. 3, 10. 4 and 20, 5 and 35, 6 and 56, and 7 and 84, okay? All right. Now, when I look at this, it looks to me like it either could be exponential or it looks quadratic. It doesn't look cubic at all. But we had just recently done this exact problem using our first differences. We did our second differences, and we did our third differences, right? We wound up getting all the same numbers on our third differences, okay? And we don't need to redo this. I did this on purpose, so we'd already done the work, okay? So we know by doing the first differences, second differences, third differences, must be a cubic, okay? So then we put in our calculator. Would you like to do that again so you can see it again in the calculator? Yeah. Okay. So these are my list 1. Here's my x's. This is list 1. This is my list 2. So I'm going to go to stat. Okay, I'm going to go on, quit. So I go to stat, edit. Now if you want to clear out your list, you highlight your list. I'm not going to do this, but you can highlight your list, hit clear, down arrow, but I don't want to do that because they're already in, right? Same thing on the list 2, which are the Y values. If I want to clear out the list, I highlight the list, I push clear, down arrow, and it clears the list. I don't want to do that because they're already in, okay? So after I put all of my data in, list 1, list 2, from stat, okay, I'm going to go to calculate, in stat. I'm going to push stat again. In stat, I'm going to go over to calculate. Okay, and I've got many choices. Okay, I really do. If I didn't know any better, I would probably go exponential. I probably would. I would probably think, man, the thing really looks exponential. But I know it's not. I know it's cubic. I know it's cubic because of what we did in the activity, right? I know it's cubic. So I'm going to go to, in fact, there's a bunch of them. You guys see all the different possibilities of logistics, assign, a manual fit. There's a ton of stuff, but what I want is cubic, right? Cubic because my difference of my Y values on the third difference worked out great for me. So, all right, I go to cubic. I'm on calculate stat, cubic. List 1, yeah. List 2, yeah. So I'm going to go to calculate. Go to calculate, put enter, and it has it for me. It actually has the ax cubed plus the bx squared plus the cx plus the d, which is really nice. It already gives me the formula. All we have to do is fill in what a, b, and c is. So if I go to my calculator, I'm going to go, okay, here's my equation. I'm going to have a y equals a 1/6, because 0.1666 is 1/6 x cubed, plus a 1/2 x squared, plus a 1/3 x plus 0. And I'll even put in the 0, even though we don't need the 0. But here's my 1/6, my 1/2, my 1/3, my 0. Okay? So this is the equation that fits these points and that data. Okay, thumbs up on that so far? Okay, and that's why I wanted to do the activity before I do the notes, because you really know what I'm doing, don't you? Okay, hopefully. Okay, yeah, I will. I'll wait for you, Gavin, you bet. So, and like Daisy said, what I really like best of all is the R value. If R squared is 1, then R itself is 1, right? Which means 100% of the data fits this curve perfect, okay? Now watch this, though. You got to be careful, because if I go to stat again, calculate, if I try the quartic, you're going to be kind of maybe amazed on this too. But they also get R. You also got a 1 on the R, but which is a better fit? We know the cubic is, right? So if the calculator is saying use either one, but the best one is the cubic, because we know that from the differences, right? And think about this. If we did the differences on this, we'd get the same answer all the way through again, wouldn't we? But that'd be silly to do it. We already found it, okay? Gavin, you ready to turn the page?
Yeah.
Okay, turn the page, okay? So, example 2. Here we go. So the table shows the population of bacteria after X hours. Find a polynomial model for the data for the first 4.5 hours. Use the model to estimate the population level in the bacteria in terms of thousands. Okay, so, all right. Let's try and do at least a scatter plot. All right. And I'm going to go hours here. And I'm going to go by 0.5. So I'm going to go 1, 2, 3, 4. So we got 4.5. So I went by 0.5s, and I'll probably go by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay? So a scatter plot, 0.5 is about 5. 1 is about 6. 2.5 is about 20. 3 is about 32. 4.5 is about 96. Okay, there it is. Now, what does it look like? I'm not sure. So, can we do the differences? Sure, let's try and do the differences and see if we get anything. So let's look at the first differences. Am I going too fast? Slow down for a second. And I like to, I'm going to subtract backwards because it takes care of not having negative values. It doesn't matter, I just need differences. So if I subtract backwards, if I go, alright, if I go my 96.125 minus my 69, and then I'll go my 69 minus my 32, and then I'll go my 32 minus my 20.625, and then I'll go my 20.625 minus 6, and then I'll go 6 minus 5.15. By subtracting backwards, I just avoid negative. I'm still looking for the differences. I'm still going to subtract this y value from this y value, so forth and so on. So I'm just going to use my calculator real quick. Let's go 96.125 minus my 69. I get an answer of about 27.125. Okay, 69 minus 32. I get an answer of about 37. And then I'm going to subtract 32 from 20.625. Get an answer of about 11.375. Okay, subtract 20.625 from 6. Get about a 14.625. And then 6 minus 1.5 should be a 1.15. Okay, now, nothing there. Let's try it again. This time I'm just going to do it. I'm going to go this minus this. So I'll go clear. 27.125 minus 37. I get a negative 9.875. I'm going to go this minus this. 37 minus 11.375. And I get an answer of 25.625. Yeah.
Just like pause for a second.
Yeah. You guys go ahead while I subtract these and I'll write them down, okay? All right, I'm just going to subtract these. I just did 37. I got to do it.
Mr. Davies,
Yeah.
you subtracted 6 from 5.125. It should be 8.75. I'm lost.
0.85, you're right. Thank you. I should have done that. I did it in my head and I didn't do a very good job in my head because you got to borrow, right? Okay, so what have I done? I'll back you up. And you just need to write the numbers down or just watch. But all I'm doing is I'm subtracting y value minus y value. This minus this, this minus this, this minus this, this minus this. And these are my answers, okay? Those are my first differences. These are my first differences, okay? Now, what I'm doing now is subtracting from my second differences, okay? And I'm just using my calculator. Okay, Gavin. Okay, those are my second differences. So that is, and I'm using my calculator. I'm just not showing it. But I'm going now this minus this is that answer. 37 minus 11 is this answer. And that's a decimal point. It's a bad looking decimal point, okay? Now I'm going to go 11.375 and I'm going to subtract my 14.625. Get a negative 3.25. Then I'm going to go 14.625 and I'm going to subtract 0.85 and I get about a 13.775. Okay, there's my second differences. Doesn't tell me anything, does it? Does it agree? Nothing. So subtract again for third differences. And again, I'm just going to use my calculator. So I'm going to subtract these two. So a negative 9.875 and I'm going to subtract 25.625 and I get an answer of a negative 35.5. Okay, this minus this, 25.625 minus a negative 3.25. Okay, and I get a 28.875. Okay, now I'm going to subtract this from this. Okay, negative 3.25 subtract 13.775. Okay, and I get a negative 17.025. Okay, there's my first. Let me write these down. Here's my first. Here's my second. Here's my third. Third doesn't look good yet either, does it? So probably quartic. Let's do the fourth, okay? So now I'm just going to subtract this from this, okay? So I'm going to go negative 35.5 minus 28.875. Whoop, yep. I get a negative 64.375. I'm going to go this minus this. This time I get a 45.95. Okay, now I'm not getting much, am I? Not getting much. I didn't get a first, second, or even a third, or even a fourth difference, right? Well, the fifth isn't going to tell me anything because I just get one number. So what do I do? What do I do?
Google it.
Google it. Use Photomat.
Don't touch that.
Let's put them in. Let's put them in the calculator, and let's test the R value for all of them. How's that sound? Okay, that's where the R comes in, okay? So we're not getting very good data. They're not good numbers, okay? So let's go ahead and put them in the calculator. So I'm going to go straight to stat. Didn't work very well for me. That's okay. I can handle that. Let's put them in the calculator. Let's go to stat, edit, clear. Yeah.
To the third and fourth power is 100% fit.
It doesn't fit?
It does fit for
The-
both of them.
For both of them. So we'll take the lowest one. Does that make sense? Great question. Okay, good. Daisy's ahead of us. Let's go 0.5, enter, 1, enter, 2.5, enter, 3, enter, 4, enter, 4.5, enter. Okay, do our Y's. 5.125, 6, 20.625, 32, 69, 96.125. Okay, got them all in there? Okay, am I going too fast? Okay, now my differences didn't work. I'm like, a waste of my time, right? Total waste of my time. It's like, why did I even do that? Didn't work, right? So then, all right, I'll go to my calculate, stat, calculate, and we could try, I don't think it's going to be linear. You guys agree? We could try linear, boom. Okay, what's the R value? 0.93, but the R squared is about a 0.8. Okay, we've got to remember that. 0.86 for the linear. Yeah, maybe. I don't know. Let's go to the next one. Okay, stat, calculate. Let's do a quadratic. R squared. Oh, 0.99. Better than linear. You guys agree? Better than linear. So throw linear out. Quadratic's better. Okay. So, but remember that. So I got a 0.99 for these guys. Okay, I got a 0.99. Got a 0.9984. Okay, I'm gonna remember that. Okay, let's go cubic. Okay, stat, calculate, cubic. Ooh, it gave me an R value of 1 on mine.
So you just did mine.
Did you get 1?
Yeah.
Oh man, so what do you think we should use?
This stuff.
Cubic.
Cubic.
Okay, so, alright, so let's go with the cubic.
Mr. Davies.
Yeah.
It also gives you an R value of 1.
On your quartic, doesn't it? Yeah. So we'll use the lowest. Does that make sense? Yeah. We'll use the lowest. So, what do I get? I've got a y equals a 1x cubed plus a 0x squared plus a 0x plus 5. Now, where did I get those zeros from? We talked about this earlier. What is this number?
So that's just going to be a 0.
Because that's going to be, move that decimal over 11 places. So this number's like point. You ready? This number's like point. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0.
So it's going to be x
2.
to the third plus 5.
Yes. There's my equation. Wow. Okay. After all that, can I tell you the moral of the story? That I put you through all this pain and suffering?